In this video, we're going to talk about intercepts of linear equations. And intercepts are places where we cross the x-axis or the y-axis. The y-intercept happens on the y-axis. And remember that on the y-axis, x is equal to 0. The y-intercept is always going to look like 0 for x and a number for y. The x-intercept, that's where we're crossing the x-axis, always happens when y is 0. So it's always going to happen at some number for x and y, 0 for y. So in order to graph with intercepts, what we're going to do is find both the x-intercept and the y-intercept, graph them, and then once we have 2 points on the graph, well, we have a line. All you need is 2 points to make a line. So to find the x-intercept, we're going to plug in 0 for y. So we're going to put 0 in and try to get x all by itself on one side of this equation. When we do that, we get 1/2. So we're going to go to 1/2 on the x-axis and put our little dot. It's not going to be perfect, I'm estimating, right there. When we're doing the y-intercept, that happens when x is equal to 0. So we're going to take our equation and put 0 in for x this time. See what we get. 4 times 0 is just 0, so that guy's gone. And we have 0 minus 2. It's -2. Could have just been gone. So we're going to go to -2 on the y-axis. Here we are. And now, if you're using paper, this is when you really need your ruler to make it look nice. So we're going to try our best to make this a straight line. It's not always simple on the internet. It's much easier with a ruler. Although if you're using online graphing software, they'll usually make a nice straight line for you. So let's try it with an equation in standard form. Again, we're going to find the x-intercept. We're going to find the y-intercept. And to remember that the x-intercept happens when y is 0. So we're going to put in 0 for y. 2 times 0 is 0. It's gone. 3x equals 6. And x equals 2. So we're going to go to 2 on the x-axis. And let's do the same for the y-intercept. That one happens when x is 0. And listen, 3 times 0 is just 0. Boom, it's gone. Don't lose that negative, though. We're going to divide by -2, and y equals -3. Here we go. Let's make our as straight as we can line. Close. Not perfect. Could use a ruler. When a graph is given and you need to find the intercepts, it's so easy. We're just looking right on there. Where does it cross the x-axis? And where does it cross the y-axis? I said those in the wrong order. So this one is the y-axis, right? So our y-intercept is 0, 2. And our x-intercept is -5, 0. We're just IDing those points. All right, on this one, it looks like our x-intercept is 5, 0, but our y-intercept is not perfectly clear. We could estimate that this is about 2.5, but I do caution you that if you don't know exactly what the intercept is, your best bet is to find the equation and then use that to find your intercept. And if you're not solving equations, plugging things in, solving for b yet, don't worry, you'll get there. And this one, I can kind of follow this pattern to find the slope and then the y-intercept of this line. If you haven't done slope yet, don't worry, estimate. It's about 2.5. On this one, look at this. There's only one spot where it crosses either axis. So both the x-intercept and the y-intercept are 0, 0 because it crosses the origin. It crosses both axes at the same time. Now, we have seen in the last few ones diagonal lines. They had a y and an x in the equation. We will also see horizontal and vertical lines. This line, y equals 2, is a horizontal line. Anytime you have y equals a number with no x's, this is almost like we had 0x plus 2. These are always horizontal lines. And they are going to have a y-intercept right there, right? The y-intercept is 0, 2. But they do not have an x-intercept. I mean, you can notice it never crosses that x-axis. So we just say DNE for does not exist. An x equals a number line is always a vertical line. And you'll notice here we have an x-intercept, but there is no y-intercept. It's parallel to the y-axis, so it is never going to cross that y-axis. The y-intercept does not exist. These vertical lines, x equals any number, are always going to be those vertical lines. You are also going to see intercepts in word problems, and units are going to be the thing that's going to help you out the most when you're looking for, like, what does this intercept mean in context? So since we know the y-intercept happens when x is 0, we want to look at the problem and say, well, what are the units for x? If x was measured in hours, then the y-intercept is like at the beginning of time, of the time. If it's measured in feet, then the y-intercept is, when it's 0 feet tall. Maybe it's a plant that's growing, right? Similarly, the x-intercept is happening when y is 0. So you can do that exact same process, but using the units for y and say, okay, well, if that thing was 0, that's what the x-intercept means, right? A height of 0 might mean that is when something hits the ground, etc. So you just want to pay close attention to the units. And remember, y-intercept, x is 0. X-intercept, y is 0. So here's a word problem for this. Below is the graph showing the straight line depreciation of a $20,000 car, depreciating, that means going down in value, at a rate of $3,000 per year. So it was worth 20,000. The next year it's going to be worth 20,000 minus 3,000, 17,000, 14,000, etc. And that's our salvage value per year. So if we're trying to decide, like, what do these intercepts mean? This intercept right here tells us our starting value, like the original value of this car when it was new. We had it for 0 years. And we know that it was originally 20,000 because that's, the number that our y-intercept happens at. Our x-intercept, and I don't have the exact number here. I'm going to just estimate for the moment that it's 6.7. This is when the car is officially worthless, right? This happens when my value, which is measured in dollars, when y is 0. So if my value was 0, that's when it's worthless. So it tells me my number of years, right? Because we're measuring x. When, or I guess until maybe makes more sense in this context, when the car is worthless. Let's say that's easier. And I'm not solving this problem right now. I'm just estimating it off of the graph. We could find the actual answer, but we're not right now.